The National Electrical Code, or NEC, addresses the requirements for electrical seals. NEC 501.15b3 states that where rigid metal conduit or intermediate metal conduit, referred to as IMC, is threaded into enclosures, sealing bushing shall be used to prevent the passage of liquids and vapors. NEC 501.15b4 states that liquid-tight flexible metal conduit shall be terminated with sealing fittings where it enters enclosures. Regarding NEMA enclosure ratings, NEMA 4X enclosures are designed to protect against splashing water, rain, snow, sleet, ice, and external corrosion. NEMA 7 and 9 enclosures are designed to be submersible in water and protect against the ingress of dust, oil, and other liquids. When considering the application to a natural gas pilot solenoid control valve, the NEC does not specifically address the requirements for seals on these valves. However, consider the following recommendations: that it is best to use seals between the conduit and feeder conduit, even if the solenoid is NEMA 4X rated, due to the potential ingress of moisture, because NEMA 4X enclosures are not designed to prevent the ingress of moisture through the conduit connection points, and this moisture can cause corrosion and electrical problems. Also, the use of seals helps to prevent gas leaks by creating a tight connection between the conduit and the enclosure. Furthermore, NEMA 7 and 9 enclosures provide a high level of protection against the ingress of liquids and dust, which is desirable for outdoor installations or in areas where there may be exposure to moisture or other contaminants. Therefore, it is recommended to install seals between the conduit and feeder conduit and the natural gas pilot solenoid control valve, even if the solenoid is NEMA 4X rated. This will help to prevent the ingress of moisture, gas leaks, and enhance the overall protection of the installation. To elaborate on these points, firstly, let's consider the purpose of electrical seals in hazardous locations. Electrical seals are designed to prevent the passage of gases, vapors, or flames from one portion of an electrical system to another. This is especially critical in locations where flammable substances may be present. The NEC mandates the use of seals in specific hazardous locations to minimize the risk of explosions or fires. Secondly, understanding NEMA enclosure types is vital. NEMA, or the National Electrical Manufacturers Association, establishes standards for electrical enclosures. These standards define the level of protection that an enclosure provides against environmental conditions. NEMA 4X enclosures offer protection against corrosion, water, and ice formation. However, they are not designed to be explosion-proof. NEMA 7 enclosures, on the other hand, are designed for use in hazardous locations where flammable gases or vapors may be present. NEMA 9 enclosures are designed for use in hazardous locations where combustible dust may be present. Thirdly, let's discuss the importance of preventing moisture ingress. Moisture can lead to corrosion, short circuits, and other electrical failures. In the context of a natural gas pilot solenoid control valve, moisture ingress can compromise the valve's performance and potentially lead to gas leaks. By installing seals, you create a barrier that prevents moisture from entering the electrical enclosure. Fourthly, gas leaks pose a significant safety hazard. Natural gas is flammable and can form explosive mixtures with air. Even small gas leaks can accumulate and create a dangerous environment. By using seals, you minimize the risk of gas escaping from the conduit system into the surrounding area. Fifthly, enhancing overall protection is a proactive approach. While a NEMA 4X enclosure may provide adequate protection in some situations, opting for a NEMA 7 or 9 enclosure with proper seals offers a higher level of protection. This is particularly important in harsh environments where the consequences of a failure could be severe. Sixthly, consider the specific requirements of the installation location. Local codes and regulations may have additional requirements for electrical installations in hazardous locations. It's crucial to consult with local authorities and qualified professionals to ensure compliance with all applicable standards. Seventhly, proper installation techniques are essential. Even the best seals and enclosures will not perform as intended if they are not installed correctly. Follow the manufacturer's instructions carefully and use appropriate tools and techniques to ensure a tight and reliable seal. Eighthly, regular inspection and maintenance are necessary. Seals and enclosures should be inspected periodically to ensure that they are in good condition. Replace any damaged or deteriorated components promptly to maintain the integrity of the electrical system. Ninthly, consider the use of intrinsically safe systems. In some cases, it may be possible to use intrinsically safe systems which are designed to limit the energy available in a circuit to a level that is below the ignition point of flammable substances. Intrinsically safe systems can eliminate the need for explosion-proof enclosures and seals. 10thly, document your installation thoroughly. Keep records of all materials used, installation procedures, and inspection results. This documentation can be valuable for future maintenance and troubleshooting. To further expand on the topic of electrical seals, consider the different types available. Sealing fittings are designed to be installed in conduit runs to prevent the passage of gases, vapors, or flames. These fittings typically consist of a body, a sealing compound, and a means of compression. The sealing compound is a non-hardening material that expands to fill the space between the conductors and the fitting body. Sealing bushings are used where conduit enters an enclosure. These bushings provide a tight seal around the conduit threads to prevent the ingress of moisture and other contaminants. Barrier seals are used to create a physical barrier between different areas of an electrical system. These seals are typically used in hazardous locations to isolate potentially explosive atmospheres. Compound-filled seals are similar to sealing fittings, but they use a liquid sealing compound that is poured into the fitting body. The compound hardens to form a solid seal around the conductors. When selecting a sealing compound, it's important to choose one that is compatible with the materials used in the electrical system. Some sealing compounds can react with certain types of insulation or conduit, leading to corrosion or other problems. Consider the temperature range of the sealing compound. Some compounds are designed for use in high-temperature environments, while others are suitable for low-temperature applications. The sealing compound should be able to withstand the expected operating temperatures without degrading or losing its sealing properties. Also consider the chemical resistance of the sealing compound. If the electrical system is exposed to chemicals, the sealing compound should be resistant to those chemicals. Some compounds are specifically formulated to resist acids, solvents, and other corrosive substances. Ensure that the sealing compound is easy to install. Some compounds require special tools or techniques to install properly. Choose a compound that you are comfortable working with and that can be installed quickly and efficiently. Consider the cost of the sealing compound. Some compounds are more expensive than others. Choose a compound that meets your performance requirements and fits within your budget. Now let's delve deeper into NEMA enclosure types. NEMA 1 enclosures are intended for indoor use primarily to provide a degree of protection against contact with the enclosed equipment or where incidental contact with the equipment would not be subjected to unusual or aggravated conditions. NEMA 2 enclosures are intended for indoor use primarily to provide a degree of protection against limited amounts of falling water and dirt. NEMA 3 enclosures are intended for outdoor use primarily to provide a degree of protection against rain, sleet, snow, wind-blown dust, and damage from external ice formation. NEMA 3R enclosures are intended for outdoor use primarily to provide a degree of protection against rain, sleet, snow, and damage from external ice formation. NEMA 3S enclosures are intended for outdoor use primarily to provide a degree of protection against rain, sleet, snow, wind-blown dust, and damage from external ice formation and in which the external mechanisms remain operable when ice-laden. NEMA 4 enclosures are intended for indoor or outdoor use primarily to provide a degree of protection against splashing water, falling water, hose-directed water, and damage from external ice formation. NEMA 4X enclosures are the same as NEMA 4 but also provide protection against corrosion. NEMA 5 enclosures are intended for indoor use primarily to provide a degree of protection against settling airborne dust, lint, fibers, and flies. NEMA 6 enclosures are intended for indoor or outdoor use primarily to provide a degree of protection against the entry of water during occasional temporary submersion at a limited depth. NEMA 6P enclosures are intended for indoor or outdoor use primarily to provide a degree of protection against the entry of water during prolonged submersion at a limited depth. NEMA 7 enclosures are intended for indoor use in locations classified as Class 1, Groups A, B, C, or D as defined in the NEC. NEMA 8 enclosures are intended for indoor or outdoor use in locations classified as Class 1, Groups A, B, C, or D as defined in the NEC. NEMA 9 enclosures are intended for indoor use in locations classified as Class 2, Groups E, F, or G as defined in the NEC. NEMA 10 enclosures are constructed to meet the requirements of the Mine Safety and Health Administration, or MSHA. NEMA 11 enclosures are intended for indoor use primarily to provide a degree of protection against the corrosive effects of liquids and fumes. NEMA 12 enclosures are intended for indoor use primarily to provide a degree of protection against dust, falling dirt, and dripping non-corrosive liquids. NEMA 13 enclosures are intended for indoor use primarily to provide a degree of protection against dust, spraying of water, oil, and non-corrosive coolants. Choosing the correct NEMA enclosure is crucial. Consider the environment where the equipment will be installed. Is it indoors or outdoors? Will it be exposed to water, dust, chemicals, or other contaminants? Select an enclosure that provides adequate protection against these environmental factors. Consider the type of equipment that will be housed in the enclosure. Does the equipment generate heat? Does it require ventilation? Choose an enclosure that can accommodate the equipment and provide adequate cooling. Consider the size of the enclosure. The enclosure should be large enough to house the equipment and provide adequate space for wiring and connections. Consider the material of the enclosure. Enclosures are typically made of steel, stainless steel, aluminum, or plastic. Choose a material that is appropriate for the environment and the type of equipment being housed. Consider the cost of the enclosure. Enclosures range in price from a few dollars to several $100s. Choose an enclosure that meets your performance requirements and fits within your budget. Remember to consult with a qualified electrical engineer or contractor to ensure that you select the appropriate enclosure for your application. They can help you assess your needs and recommend the best enclosure for your specific situation. In the context of natural gas pilot solenoid control valves, the selection of the appropriate NEMA enclosure and the use of proper seals are critical for ensuring safety and reliability. By understanding the requirements of the NEC, NEMA standards, and local regulations, you can create an electrical installation that is both safe and compliant. To summarize, when working with natural gas pilot solenoid control valves, remember these key points. Always use appropriate seals to prevent moisture ingress and gas leaks. Select a NEMA enclosure that provides adequate protection for the environment. Consult with qualified professionals to ensure compliance with all applicable codes and regulations. Install all components properly and according to the manufacturer's instructions. Inspect and maintain the installation regularly to ensure continued safety and reliability. By following these guidelines, you can minimize the risk of electrical failures and ensure the safe operation of natural gas pilot solenoid control valves. Furthermore, it's crucial to stay updated on the latest revisions and amendments to the NEC and NEMA standards. These codes and standards are constantly evolving to reflect new technologies and best practices. By staying informed, you can ensure that your electrical installations are always up to date and compliant with the latest requirements. Consider attending training courses and seminars on electrical safety and hazardous locations. These courses can provide valuable information and hands-on experience that can help you improve your skills and knowledge. Join professional organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the International Association of Electrical Inspectors, or IE. These organizations offer opportunities for networking, education, and professional development. Read industry publications and technical journals to stay abreast of the latest trends and developments in electrical engineering and safety. Subscribe to online forums and discussion groups to connect with other professionals and share your knowledge and experience. By actively engaging in the electrical engineering community, you can expand your knowledge, improve your skills, and contribute to the advancement of the profession. In conclusion, the safe and reliable operation of natural gas pilot solenoid control valves depends on careful planning, proper installation and ongoing maintenance. By understanding the requirements of the NEC, NEMA standards and local regulations, and by staying informed about the latest developments in the field, you can ensure that your electrical installations are both safe and compliant. Always prioritize safety and consult with qualified professionals when in doubt.